Hi folks, this is question 5. First bit, we just need to see that it has to be the same number that's in between each part here. And in between 7.2 and 8.4, you're trying to see what is halfway in between those two. And that's 7.8. So the difference in between all the numbers each time is 0.6. If you go back 0.6 from 7.2, then you get 6.6. And if you go forward 0.6 from 8.4, you get 9 exactly. And that's all that is there. We're trying to see then what percentage of the sample got at least 9 hours sleep. Well, at least 9 hours sleep on the diagram would look like everything to the right of the 9, so it's everything in. Now with the empirical rule, everything between the first two standard deviations there is 68%, and that's told to us up there. But everything between the next two, between the 6.6 and the 9 here, would be 95%. And then the next two out would be 99%. That's the empirical rule, but we don't need that here, need the last bit here. What we need to see is that if everything there is 95%, so if everything within those two is 95%, well then the last two bits on the outside would have to add up to 5%. So that would be this bit in here, and the bit that we actually want. So the bit that we actually want is going to be half of 5%, and that's all it's going to be. So it's just going to be 2.5, so 2.5%. So you have to understand the empirical rule there for that. Now this bit here then, so the probability that he gets the recommended amount of sleep is 10%. So then if that's 10%, well then the probability that he doesn't get the amount of sleep has to just be 90%. So if just 10% of is the probability of something happening, the probability of it not happening is the opposite. So you just do 100%, take away 10%, and that's 90%, and that's all that question is. Might have confused some people. For the next one then, if we break it down into 3 nights, so the first night, the second night, and the third night. On the first night, we want him to get the recommended amount of sleep for the first time on the Tuesday night. So we don't want him to get the recommended amount on the first night. So therefore the probability that he doesn't get the amount on the first night is just going to be the 0.9. And then the second night as well, we're going to multiply all these afterwards. Second night then, we don't want him to get the recommended amount on the second night either, because we want him to get it on the third night. So that's just going to be 0.9, and then we want him to get it for the first time on the third night, and that probability that he gets the recommended amount is 0.1 or 10%. You could put them in as percentages if you wanted there, and then we'll just multiply all those together and you get 0.081. And that's it. That's for that question.